In this video I'm gonna treat the intermediate puzzle Eclipsing Earth, shown over here, and it features two circles, a large blue one with its center C, and a smaller yellow one with the center on the blue circle E, and a cyclic equilateral A, B, C, D. So it's cyclic, that means that there is a circle through it. I will demonstrate that. Let's see, over here. A, B, C, indeed, you see that the D is also on that circle. So it's cyclic. And the diagonal AC is exactly the radius, the extended radius through the center E. And the puzzle is to prove that, well, that there is also another condition, is that BA and AD are tangent to the smaller circle. As you can see, they are tangent. And the question is to prove that BD is also tangent. I will draw it, BD, and you can indeed see it is, but we need to prove it. It is also tangent. So in other words, the small circle is the incircle of the triangle ABD. So we have to prove that. Well, first of all, the easy part is, well, what we're going to do, the approach is the approach of Stéphane Bernard, and it is to use the fact that the incircle, the line through the center bisects the angles. So all three angles are bisected by the line through the incenter E. Now here it's obvious that it does, because those are two tangents, and the tangent theorem states that, let's call this angle X. Over here we have an angle X, and over here we have also an angle X. That's basically the tangent theorem. Those angles are the same. That's because those are two tangents. But now we're going to prove that this line is also bisecting the angle ADB. And if we have proven that, then it's well known that also this angle is bisected. So that's enough basically to prove that those two angles BDE and EDA are the same. So let's name this one Y. We have an angle Y over there. And now we're gonna first use the fact that the angle at the circle is exactly half the angle at the center. That's a well-known theorem. So the angle at the center, BCE, is twice that angle. So we have 2y. Here we have the angle 2y. That's because this angle is at to the circle, and at the center it is doubled. Well, now we're going to use the fact that this is a cyclic quadrilateral, which means that the angle BCA is the same as BDA, which is 2y. Well, because we had already 1/2 is y, that does mean they add up to 2y, so this one must also be y. And there we already have our desired result, which is that those two angles are the same. Those two angles are the same, and therefore the yellow circle is the incircle of this triangle, and therefore BD is also tangent to the yellow circle. And that completes the proof of eclipsing Earth.